Hey, I pushed a button and it did something. So today's topic is legacy migrations from Ultra 3000 to Kinetix 5100. So I'm not gonna, since we've only got a half an hour, we will get your presenters, Joe Belaski, myself, and Mark McGinnis. So I'm again based out of Houston. Mark is out of Dallas. But have a couple coming up. So we've got users group webinars and tech talks. So we send out invitations on those. They're available. Register for them. So we have a few more coming up, a bunch of really good topics. And any specific topics you would like us to add to this list, please let us know. There we go. We also have an event going through the 19th. Registration should open any day now. They've been promising us that it would be open by now, so it should be open very soon. There are a bunch of online seminars. We'll do us know when registration does open so that you have first access to all of the labs. Should be a very, very good event, and it will be a completely Rockwell events. There we go. This seems to be, I think I'm having some issues with advancing slides not as fast as I want to. All right. So one of the main things that we want to talking about migrations, it's very useful to know what you actually have in your plant. And with that, yep, I am flying through these slides for me. Go back a couple. I'm having too much lag on my end, and they're kind of doing whatever they want. Thank you. So the important thing about having your plant so with Rockwell has a service where we can actually come out and go through your plant and tell you exactly what is most of our customers that would love to know exactly what's in their plant. Some have a very, very good understanding of what's in their plant, and there's maybe not so much, or it's not as much as you want. How your products fall into the life cycle. And so with the life cycle of Rockwell products, there is active, mature, and there's what we want and discontinued. And sadly, there's a few of us that have some discontinued product. And so with the goal there is to really see what you have in your plant to support those older products and to help you make a decision on what should we look at doing. When do we want to make a move forward, an update? If the machine is going to be replaced by a new machine in a couple years, it doesn't really matter. Being able to upgrade one machine and use those as spares. So very useful to be able to have that made. Slide, please. So to help with that, if you don't go through the process of the install-based evaluation, Rockwell actually has a tool built on their website called the Product Lifecycle Status, where you can type in any individual gives you definitions of what those status mean. Just because something is discontinued doesn't mean that you can't get it repaired. Just an FYI on that one. So if it are sure, and so there are replacement options out there for a majority of them. In this case, the Kinetix 5100, and they are to um, but they're definitely a very good product, and they're still available. So next slide, please. All right. Yeah, uh, I'm having horrible lag. So the discontinued product is still that continued is no longer available for sale as new. Rockwell does have an extensive remanufacturing program for doing exchange repairs, and we can do those in on the shelf. So keep that in mind whenever you have something that you can't get anymore, that we can try to work with you to get access to a remanufacturing service with Rockwell. The also an up to 24-month warranty. Something else to keep in mind. I think that's all of the bookkeeping we have for today. The technical. Next slide, please. There we go. So one other piece of thousands here is the life cycle status. So the amount, and as you can see, that they're telling you that we're not near the end. So we have a little bit of time left on the Ultra 3000, but they are also have a lot of new opportunity to support our newer control systems. They also give a few suggestions on migrations in that document, which I have listed. Servo drive part number. There are some suggested replacements already put together for this. When you're looking at the Ultra 3000 applications, there's a bunch of different variants. That's one of the things that made the Ultra 3000 such a great drive, is there's a completely standalone. You can have them out there doing following over DeviceNet. You can have them doing being controlled over Circos. So completely out there, and they also supported a whole bunch of different motors. So there's with that, the migration path for an Ultra 3000 is sometimes, and we can see in here where we've got a control that's the analog control, a digital pulse train control, and indexing style axis, or even DeviceNet, where we solution. If you had one of the few Ultra 3000s out there that was running on, we would look at, since at that point you've already got all the motion code built inside of one of our control, would look at converting that over to SIP motion over Ethernet and using a Kinetix 5100 or 5700. One of the other particularly important is also the except for the ones with resolvers and the new TLP motors. Next slide, please. So when we're talking about doing a migration, we've got a lot of things to consider. I know there's a lot of words on this slide. I do apologize for that. the depth because I believe it's very important. The that you're trying to really look at when you're doing one of these conversions is how difficult is this going to be, and things I use that word, but basically, can the application be easily migrated or reused? So if you're using an Ultra 3000 in an index format, there's a new set. You can't actually take the program out of it and just dump it into the new drive, but it does have the same programming features. If you're looking at something other than an Ultra, then a little bit more work on migrating the code. So that is one of the main pieces to look at is what is the engineering time required on the programming side and the application. There is also a bunch of information we need to look at on the motor. So when you're looking at a servo system that's in an drive or just the motor, the whole system must work together because they run in closed loop. So not only the drive important, making sure the drive is sized properly, but it's also very important to make sure and that is sometimes a problem when it comes to legacy and migrations is the type of feedback that won't work with one of made anymore. So that's one of the main things that we want to look at is are we going to be keeping the existing motor, and if we can keep the selection, what type of drive. If you are changing the motor, that is, it's a great time to change the motor as you're replacing the drive, but that also requires a little bit will physically fit in the application. Sometimes new mounts and sometimes new gearboxes are required, and also that the cables. So there's a lot of stuff to look at there. And then when you're going to replace the drive, there's things you need to look at in the panel, like is there room? Will the wire found one that actually works? All of them seem to just break the wire in half, and you have two short pieces of wire. So that's important to make sure that we can actually mount the drive on the what type of controller you're going to be using. Is it a fully integrated drive, over Circos or Ethernet? Is it standalone? Is it indexing? Are we signal that says go? Is it being controlled via analog or a pulse train output? And is the control system going to be able to support the new looking? And then what is a power rating? That's the one that most people start at, but that is not typically one of the places because there's so many other is the motor because you can't there are cable length limits, and sometimes what worked on one system could have been up to maybe 90 meters. In most cases that isn't a problem, but every now and then it is. And one last piece is we're here to help. So if you have a migration application forward, if it seems to be a little more complicated where to begin, we're here for you, and we can definitely help you with those type of asking the right questions. And really it's going to be about trying to, one, are we going to just them, or are we going to upgrade it? That's next of these. Is there an upgrade opportunity there to improve production, improve reliability, improve sizing, improve heat control, whatever the application is. So to help with the sizing of these systems, Rockwell has already built a very nice tool called Motion Analyzer. And basically just create, and it's a web-based tool where you can go in and put all of your motion information. So what your curves look like, or what the inertias need to be that you know of, and have it create a solution for you. Uh, it's important to use this tool sometimes when we're converting some differences in the way that people evaluate motors, and there's differences in the way people look at certain dynamics and different statistics of RMS versus peak to peak versus zero to. There's a bunch of differences in certain pieces. So just a few of the things that are listed here, rating methods differ, like I just talked about. There's a difference in a really as big of a deal I think it is, but in a few cases it's extremely critical. So you want to have an inertia ratio that is appropriate. Now, when converting motor has all of the other same characteristics, but 2 times the inertia, you have a whole bunch of extra resistance, and you're going to read to motion, and you on that, just the extra weight inside the motor, and so that could give you some issues with being underperforming or basically undersized. The motor's now undersized because it can't do matched. So very useful to be able to have Motion Analyzer go through and actually do the kinematic equations and measure all the dynamics and have all of that info for you. That's pretty standard across the board. I think most people like to do that. Um, it works really well. It's actually not typically a problem, other than it can be very expensive. Actually, for really no reason, and a lot of extra drive, an extra motor, and every now and then, if the system is a high speed, high precision system, it can actually, sizing up isn't always the thing to do. Next slide, please. So when we're looking at kinetics, the capability of basically using almost all the exact same type of controls. So if you look at the table off to the right, we have basically for every type of drive have an equivalent in the 5100. I included the abbreviations off to the right so that you could actually see what those mean. So the configuration of the 5100, which is integrated into Connected Components Workbench. So you can there is a migration manual out there that will walk you through Kinetix 5100. That's exactly where that table on the right came from. So it's only about 90 pages. It's a quick read. Um, I didn't fall asleep on though. So if you're running the thing in the new drive in standalone, we basically have, you can replicate the parameters into the existing drive from the existing drive and set the IO to differences on the IO from the Ultra 3000 to the Kinetix 5100. But in general, all of those subtle differences are an improvement in addition in adding functionality. They're actually networked application where you're looking at a Circos style integration. We should probably be looking at a different, maybe a Kinetix 5500. If you're using a device net, you have have an add-on profile for version 30 plus of Studio 5000 and a whole bunch of add-on instructions, different types of motion commands inside of the control. If you're using Connected Components Workbench, there's also a set of instructions in there, and all of those are going to be based off of message instructions out to the drive. Next slide, please. The Kinetix 5100 currently supports all of the MP series motors, except for the ones with resolvers, and the TLP motors. So when you're trying to replace them, so I've got a giant list of look at. So, you've got the main ones people look at is torque, like what torque and speed and power, and then, up in the list. And then they look at feedback type, making sure that the motor will actually to the drive and the drive can understand it, which is very important. You can select the best motor in the world, but if it isn't going to physically fit, that's something that's very important to look at. From different platforms, from the old are sometimes different on the MP series or on the TLP series. The pilot sizes, the bolt circles, all of the mounting dimensions, stack length and cross section. They're not that, maybe 5%, but sometimes they're a lot different. And so we can work with you and work with different manufacturers to select new gearboxes or out just the face, the mounting face that the motor mounted to. So they were able to keep the gearbox and rebuild in one mounting face. That isn't always the case, but on the new motor in place where the old one was. It's also important to look at those curves on the right. So we've got these different curves published of the torque, and is constant up to a certain speed, and then it breaks and starts decreasing as you go faster. So when you look at that continuous torque rating in the graph or in a list, it's going to be that 2,000 RPM, then that continuous torque rating actually starts dropping. So you can't assume that that continuous torque rating is going to work at full speed or even at 5,000 RPM. So it's important. Next slide. So on the 5100, dimensionally, it's smaller than the Ultra 3000, which is good. The Circos should be migrated to Kinetix 5500 or a similar platform. The net would definitely convert to Ethernet, and you can see we've got some of those arrows aren't lining up properly. And the shunt is built into a majority of the 5100s. So the internal thermal of the Ultra 3000s. And then there's also safety built in. So when you're looking at migrating an application, sometimes it's a good thing to upgrade. And you're so look, adding one of the ways that we used to do safety on the Ultra 3000s was just cut the power to the drive. That's not necessarily the most polite thing to do to a piece of solid state equipment. actually have a safe condition where the motor will not receive enough current to create torque. Now there's still going to be voltage on the motor, so don't just hit an e-stop and disconnect the motor. But safe torque off. So, and we've got the mounting plates, feedback connectors. There is an I/O breakout, so we can help you when ordering one of these application. Next slide, please. So we put together a list of all of the different useful links, publications. Some of these publications are I'd say very long-winded. And for instance, the user's manual, UM00, full links on converting from Ultra 3000 to the Kinetix 5100, the different parts in the 5100. One last thing to talk about when it comes to the 5100 is current 100-volt version, the 240-volt version. The 480-volt version is supposed to be out toward the end of this year. So last I heard was August. Be a little earlier, a little later, typically around that time frame. We should expect the 400-volt version of the drives to be out. So again, we can assist you with any of the migrations that you've got. I think that is it. So there's a question. Support Sercos. That application would migrate to Ethernet. It would migrate to Ethernet IP and preferably SIP motion. So because when you're doing the Sercos, our motion commands in an integrated fashion, and all those motion commands are effectively the same when doing an Ethernet IP SIP motion axis. So try to convert to that. There's a manual. That's on that. In that case, we would typically migrate to a Kinetix 5500.
Pretty much everything is going to Ethernet. All of I/O and motion and safety and everything. So everything's handled over Ethernet today. One for attending. This Thursday, we're going to talk about migrating PowerFlex drives. Well, I'm sorry, we're migrating the Bulletin 160. Bulletin 160 and 1336 and 1305 drives, legacy migration to PowerFlex on this Thursday at 10 o'clock. And we look to see you in a future Tech Talk.